You want to start with 1?
Sure. Yeah, definitely.
So what's the volume of that sphere?
Okay, so you would do 4 over 3 times pi times 6 squared.
Correct.
Cool.
And then I would cancel that and make that 12. So I'd have 48 pi.
Right.
Okay. About number 2.
Okay, so for number 2 we would do this one would be, yeah, so 2/3 pi times radius cubed.
The radius is 24.
It's 24, yeah.
But that's the volume of a hemisphere.
Right, but this has a chunk cut out.
Yeah, so how do we handle that? What part, always think of what part of the hemisphere do we have?
Okay. So we would do 360 minus 80, right, to get
Good.
the other part. Cool.
So that's 280.
Uh-huh.
Over, you got to divide it by the 360.
Right.
That's the fraction of the hemisphere that we have.
Uh-huh.
Is 28/36 of it.
Okay.
In other words, if that was a 90-degree angle, we would have 3/4 of the hemisphere, right?
Right.
And you always get that fraction by taking the degree measurement divided by 360.
Okay. Yeah.
So number 3, this is a volume problem, okay?
Mm-hmm.
What is that figure called?
That would be a triangular prism, right?
Okay.
Cool.
So,
so we would just do base times height times, oh yeah, just base times height
area of
times
the
length
base
divided by,
times the thickness between the equivalent bases. And the area of the base is 1/2 of little b times h times h again. And notice that this h is not the same as that h. This h here is the thickness between the two bases.
Right.
This h here is the height of that triangle. So be careful when you're doing this, that we've seen this before. With the trapezoidal prism, we're going to have the same problem. With this problem number 4, the h of the trapezoid is not the same as the h in the volume equation.
Yeah.
So you can use a subscript or whatever, but just don't get them confused and make sure you know what they are. So for this problem, what is it? Oh, they don't give us the h.
They don't.
We got to figure it out. So
let's draw. Could we just do the Pythagorean Theorem to find the height? So we would just do 25 squared minus 24 squared is equal to, cool.
Well, not quite. It's the square root of that.
Is equal to...
Well, always remember that when you are solving a right triangle, the answer is always begins with square root of.
Okay.
So x is the square root of 25 squared minus 24 squared.
Okay.
I believe that it's 7, but I'm not... Do you have your calculator?
I do. 23 times 23. So 529
it's
minus...
25 squared, not 23.
Or yeah, 25 squared. Did I do... Yeah, so 625 minus... That's 24. So it'd be 5... What was 25 squared?
625 minus what?
625 minus 576.
Should be 49.
Okay, yeah.
And then the square root of 49 is 7.
Is 7. Cool.
And that is one of your smaller perfect Pythagorean triangles. A 7, 24, 25.
Right.
So now we can do the base. Tell me what to fill in for each of these.
Okay, so we would do 1/2 24 times 7 times the height.
Which is?
11.
Yeah. It's not really height. We call it height, but what it really is the thickness between the two bases.
Yeah.
That's what it is. When you're figuring out the volume of a prism, that h is the thickness between the two equal, opposite, and parallel bases.
Right.
All right, number 4. Similar problem. What's the general equation?
For number 4 would be base times height divided by 3.
And the base, what's the equation for the base?
So it'd be volume is equal to base 1 plus base 2 times height divided by 2.
And again, that's not the same height. So I'm going to call that H1. So that's our equation. And let's fill in. In other words,
wait, so it'd be
a number. It's nice to start with the general equation. And then fill in everything and solve the equation. What's base 1?
Right. 15. So it'd be 15 plus 22, which is 37 divided by 2 is 18.5.
Well, let's leave it like this, and I'll show you why.
Okay. Cool.
We might be able to get rid of that 2 without involving fractions. In other words, the fact that you turn that into 18.5, too early. Too early to do that. We may not need to do that. We may not need to bring fractions into the problem. We may be able to solve it other ways. In other words, let's write it like that. What's the height?
The height was, or is, 8.
And what's the H1?
36.
Okay. Now notice that I can get rid of that 2.
You can, yeah, because they cancel out.
So now the volume, I don't have to deal with fractions. It's 15 plus 22 times 4 times 36.
Cool. Divided by 2.
No?
Or no, we don't. Nope, just leave it like that.
And that's why I didn't want to divide 37 by 2. Because then I would have had a fraction, and it creates more places to make mistakes.
Right. Yeah.
It's kind of the secret of math is try to keep all your coefficients positive and try to keep fractions out of the problem if you can.
Right. Yeah.
So, number 5. Tell me everything to do.
Okay, so you'd set 972 pi equal to 4 over 3 pi r cubed.
Yeah. Actually, what I would do would be always start out with the general equation. Now, this is a little different because they're giving you all of these.
Right.
And so maybe I don't have to write it because somebody already wrote it right there. But I would still do it like this.
Okay.
Now fill in everything you know.
Okay. So now we would do 972 pi is equal to 4 over 3 pi times radius cubed.
Okay.
And then
there's only one variable in that, and that's r.
Right.
So once I solve for r, I'm going to know diameter by doubling it. Let's see if there's anything clever we can do here.
Yeah, pi's cancel out. Yeah, so it'd be 9.
And then what's the next thing you do?
You'd multiply 4/3 on both sides. It's already being divided.
Hold on. You want to multiply by the reciprocal of 4.
3 over 4.
Because we want to get rid of the 4/3. If I
Right.
multiply both sides by 4/3, which is what you said, I don't get rid of the 4/3. It turns into 16/9.
Right.
So the only way I get rid of it is if I multiply by the reciprocal, 3/4. Now I have to multiply the left by 3/4 also.
Right.
Okay? So now I get r cubed equals whatever that number is, and then I'll bet it's a perfect cube number. So you'd be able to figure out r, and,
Yep.
And then diameter would be 2r.
Right.
Do you have to turn this in? Do you need a number on it?
We don't have to turn this in. It's just review, basically.
All right. And if it's just review, I don't feel compelled to get a number.
Right.
That's just arithmetic.
Right.
If you had to turn this in and you had to answer it anyway, well then I would say, well, let's go ahead and get a number. But number 6.
Okay.
Start with the general. Always.
Right.
Even if they give it to you. Because they give us 4 different formulas there.
Yeah. We would do volume is equal to pi r squared times height.
Hold on. What's the volume of a cylinder?
It's 4 times radius cubed divided by 3, right?
No.
4 times pi.
No, hold on. A cylinder is a prism.
Oh, a cylinder. I'm thinking of something else. I don't know what I was thinking of. But, yes, it'd be base times height for a cylinder.
What would that equal here?
Pi
Pi r squared times h, right?
Right, yeah.
So that cannot be the volume formula for a cone, because a cone looks like this. So what's a cone have to have in addition to the pi r squared h?
You would have to divide it by 2.
3.
Or 3, because it's, yeah.
It's 1/3. Remember that when it goes to a point, it's 1/3 of what it would have been if it was a prism. And it doesn't matter whether you're talking cones or triangular pyramids or rectangular pyramids or whatever kind of pyramid. If it goes to a point, it's 1/3 of what it would have been if it was a prism.
Yeah.
Okay? So you don't want to make this mistake that you made. You didn't put the 1/3 in. And I prefer to put it in front at the get-go. It's not, to me, it's not pi r squared h divided by 3. To me, it's 1/3 pi r squared h.
Right.
Okay? Now fill in everything we know and everything we don't know.
Okay. So it would be 448 pi is equal to 1/3 pi times h squared times height divided by 3.
Okay, don't do the 1/3 twice.
Yeah, I was looking at my paper because
Well, I'm kind of confusing you, I imagine, because of insisting that it's just the way I memorize stuff. I prefer to put the 1/3 first, just like I put all my 1/2s first. Area of a triangle to me is not base times height divided by 2. It's 1/2 base times height. In other words, I get my fraction first. Okay? I don't want to forget the fraction. But you don't want to do it twice either. So you certainly don't want to do 1/3 of all of this and then divide by 3 again.
Yeah.
Okay. This is also rather straightforward. Can't do much here. So that's going to be 64 over 3h. Now, how do I solve it from this point?
Alright, and then we could just see 64 divided by, or no, that'd be harder.
Tell me exactly what to do.
We do 448 times 3 divided by 64.
Okay, that's all right. I have no problem at all with you doing that in 2 steps. It actually makes more sense to do it in 2 steps. Okay? In other words, get rid of the denominator and then get rid of the coefficient. But notice what you did. You multiplied by 3 and then you divided by 64. That's the same as multiplying by the reciprocal of that.
Right. Yeah.
So that's when I want to do the other side. In other words, if you want to do it in one step, you can. But you have to multiply by the reciprocal, not the fraction.
Okay.
So h is equal to that. But doing it in two steps is kind of like cross multiplication. Let's look at cross multiplication for a moment.
Okay.
If I had this, everybody says cross multiply. Well, that's fine, but what is cross multiplication? It's multiplying both sides by 6 and multiplying both sides by 9.
Right.
In other words, it's just putting one step, it's taking two steps and making it one.
Yeah.
So I immediately do both things, and it saves me one step by cross multiplying.
Right.
Although, notice that I don't really want to cross multiply here. I want to just multiply both sides by 6.
Yeah.
So what I really have is that. And cross multiplying is a little self-defeating, because after I cross multiply, I then have to divide by 9. Well, I just multiplied by 9. So it doesn't make sense to multiply by 9 and then divide by 9. Just don't multiply by 9 in the first place. But in other words, now that can be simplified rather easily. 90 over 9 is 10. So I get that, the answer, but don't automatically cross multiply just because you can. And kind of similar thinking when you have a fraction as a coefficient that you're trying to get rid of. You can do it in two ways: multiply by the denominator and divide by the numerator, or just multiply by the reciprocal. But make sure you don't divide by the reciprocal.
Okay.
In other words, always make sure that whatever you do, it cancels. If I multiply by the reciprocal, you can see that the 3's cancel and the 64's cancel.
Yeah.
And that's what you want, is for everything to cancel. So.
Okay, that makes sense.
All right. Determine the density of an object that weighs 2,500 grams. Well, density is volume per, or grams per volume.
Okay. Is it volume over grams, or?
I think it's density is grams per volume.
Okay.
If I'm talking about gold, I'm talking about a certain weight per cubic inch or whatever.
Right.
Okay? But it's rare that I'm talking volume over grams. Okay? So I want weight over, in other words, density is weight divided by volume.
Okay.
All right. The object is put in a cylindrical container that has a radius of 8 and a height of 12 and causes the liquid to rise 3.5 centimeters. Well, let's just draw that for a moment.
Cool.
This thing had liquid in it at the 12 centimeter mark.
Right.
It's full of liquid.
But you wouldn't want to use 12. Like 12 doesn't even go into the equation, right? Because you just have to rise.
Getting there.
Yeah.
Okay. When you put this object in the water, it rises up to there.
Okay.
Water level.
Right.
And I could call that 15.5. But what really matters is that height right there. That's 3.5.
Yeah.
And what we're looking for is, what is the volume of that? So what is the volume of that?
The volume of that, so it'd be volume is equal to 3.5x.
Well, hold on. That's its own little cylinder. We got a radius here of...
Right, so it'd be pi r squared times height.
Radius is 8.
Yeah, so it'd be pi
r squared times height, which translates to what for our problem?
Which is equal to pi times 8 squared.
So that's 64 pi. What's height?
3.5.
Exactly. In other words, that's its own little cylinder.
Uh-huh.
We can completely ignore the rest of that soup can. The only thing we don't need this 12 and that 15.5. I could figure out the volume up to 15.5 and subtract the volume goes up to 12. And that's going to be the same answer. But it's much more direct to just take the change in height, which is 3.5, and multiply it by the pi r squared.
Right.
And so what's that number? Well, let's see. What are they asking for? They're asking for determine the density. So
I got 224 pi.
How much?
224 pi.
Okay, so if the density is weight, it's 2,500 grams divided by 224 pi. What are the units on that? Centimeters cubed.
Yeah.
Whenever you're talking volume, it's going to be cubic something. If you're talking area, it's going to be square something. If you're talking a linear measurement, it's just going to be in centimeters.
Right.
So now the question is how to present the answer. Well,
I got 11.16 pi is equal to the density.
Okay, you got pi in the denominator.
True.
So it would be 11 divided by pi. But that brings us to a question. Pi is an irrational number, and we're dividing by an irrational number. So when I wasn't exactly sure what the proper answer should be. What'd you get for 2,500 divided by 224? 11 point something?
Yeah, 11.16.
But it's divided. The pi is still down there. Okay.
Right.
So either you can give that as the answer for density, or you could go ahead and divide that number. I don't know, did you round that number off, or was it exactly 11.16?
It was exactly 11.16.
Okay.
Or, yeah, actually, it was 11.1607, etc.
So there are other things. Okay.
Yeah.
If that's the case, then go ahead and take your answer, the full answer with all the decimals, and divide it by pi, and what do you get?
So you would get...
divide it by the pi key.
Right. Let me do this. 11.1607 divided by pi. I got 3.554.
All right. And they didn't really say how many decimal points to round it off to.
No, they didn't specify. Yeah.
I got 3 circles on my page. Which is the most accurate answer?
I feel like 11.1607 over pi.
No, this one right here. Because you got that 11.1607, there were some more decimals after that, right?
Right.
So you actually rounded that off, even though you rounded it off to 4 decimal points, which is impressive, but it's still rounded off.
Yeah.
Whereas 2,500 divided by 224 pi, everything is exact there.
Yeah.
There's, if that density, if it was important for it to be to the nearest 10,000th place, I would want to go up here and use that number, not that number which is rounded off, and that number is definitely rounded off.
Yeah.
There's 3.554. There were more decimals after that, I'm sure, also.
Right.
So I'm not sure what the answer they would like to see on this is.
Yeah.
Probably something like that. In other words, 3.55 grams per cubic centimeter would be probably an acceptable answer. But that should be an acceptable answer be honest with you, I'm not quite sure. You can't rationalize when you divide by pi. In other words,
No.
typical irrational denominators look like this, okay?
Right.
And I can rationalize that by multiplying by that over that, which gives me square root of 2 over 2. So I can rationalize it when I have an irrational denominator like that. But if I have 1 over pi, there's no way to rationalize that. There's nothing I can multiply pi by and make it rational.
Right.
So that has to be an acceptable answer. And in this particular case, since pi was in the denominator, I'd be inclined to leave my answer exactly like that. 2,500 grams per 224 pi cubic centimeters.
Yeah.
All right.
Cool. Awesome.
Well, you take your final on Thursday, is that right?
Yep.
Or is it in two parts? Have you already taken part of it?
We haven't taken part of it. I think there's only one part.
Okay. Because I have other students that it's a 2-part final.
Gotcha.
In fact, Hansak's class.
Yeah.
I think they
Yeah,
do the
that's
final on Monday and Thursday, or Tuesday and Thursday, one or the other.
yeah, something like that.
So yours is all just Thursday. Okay. We got one more session tomorrow night, same time, same place.
Yep. Awesome.
All right, Dylan. Talk.
All right.
Bye-bye.
That sounds good. Thanks, Mr. Cowan.